Greeting class, my name is Daffari Putri Utami with student ID 19063016020. In this video, I will talk about the simultaneous linear equations. These are the contents that I will talk during my presentations. First is linear algebra, second direct and indirect methods, third Open Modelica application, fourth is the results. First, linear algebra. Linear algebra is an equation that can be represented as a product of matrix or as an augmented matrix. There are also special types of square matrix with unique properties. If you see the picture below, these are the examples of linear algebra equations that are represented as a matrix. Direct and indirect methods. So to solve these equations, we can use direct and indirect methods. First, direct methods. So with direct methods, you have to calculate the solution after performing a finite series of computational operations. This method is based for solving small and filled matrix. The examples of these methods are Gauss elimination methods and Gauss-Jordan methods. Second, indirect methods. These methods approach the solution by improving an initial guess until the error is negligible. This method is best for solving large and sparse matrices. The examples of these methods are Jacobi method and Gauss-Seidel method. After this, the third, we're going to talk about the application in Open Modelica. So we're going to try to solve this equation, this exercise problem with Open Modelica in the help of Open Modelica with simultaneous linear equations. What is the exercise? What is the problem? So the members of the truss shown in the figure, have a cross-sectional area of 10 centimeters squared and are made of steel with 200 gigapascal. And using Open Modelica, we have to determine the deflection of each joint, where the stress in each member, and what is the reaction force. Now we're gonna talk about how to solve these problems. So there are few steps that we have to follow. First, we have to discretize the problem into nodes and elements first. Here we have the master file, which is trust.w.mo. So first, we input the parameters and some constants that we will use from the question that have shown in the previous slide. And after we input the parameters, after we discretize the problem into nodes and elements, we assume a solution that approximates the behavior of an element in the same master file. So as shown in the picture, there are 5 trusses, and then we input the parameters that is shown in the questions, that is stored in the question. There are degree between truss and stiffness matrix. For each of the truss, we input the parameters. And after that, we develop the equation for elements. So we will make a called function. First, we will make a called function stiffness matrix for making the to make the matrix for the each of the trusses that's shown in the previous slide. We will make the matrix with these equations, with these called functions, and after that, in the next steps, after we define the matrix in the previous file or function, we will assemble the elements in the local global, and here we will assemble the truss that had been defined. And after that, we apply the boundary conditions and loads. We see in the pictures shown there are some fixed places. So because there are some fixed places, we have to apply the boundary conditions to perfect the examination. After that, after we make the code, we solve the system of algebraic equation simultaneously with Gauss-Jordan way, which is direct method. We use a called function Gauss-Jordan for this, and then after that, we obtain another information too, which is reaction traces, because we have to look for reaction traces with another code function here, shown here. And then after that, we will get the results. We will go to the Open Modelica directly for this. And then here are the methods, the codes that we already run. We can see this is the graph for the R, and these are the numbers of answers. And also, after that, we will look at the solve. Here are the graph for the solves, and here are also the numbers of answer for the reaction, not the reaction, for the traces, each of the traces. That's all from me. Thank you very much for listening my video. And last but not least, I have a quote to share. It's from Sri Chinmoy, a philosopher. She said that gratitude is the sweetest thing in a seeker's life. In all human life, if there is gratitude in your heart, then there will be tremendous sweetness in your eyes. That's why don't forget to always feel grateful no matter where you are and when, and stay conscious.